Okay, this is the final presentation for the Trojan Map project for the EE538 course.
So this is the overview of the PPT. We have implemented the following functions in the project, which we will be explaining in the upcoming slides.
Okay, we're going to start with the autocomplete function. Given the partial prefix of any location present in the map or the graph, which should return the complete names of those locations. So we're going to start with TA, and we have tap to blue and the target as the locations, and CA. Like we have like 5 locations which match the prefix. Those are Carson Center, California Family Pharmacy, Kava, Calhoun All-Star, and Colmar Beer.
So this is the second function. Here we are finding the location. So the user inputs a location and the function returns the latitude and longitude from the given data. In the second image, you can see that the user has made a mistake in the spelling for the location. So the function first tries to find a similar location and then asks if it's the correct location. If it is, then it gives the latitude and longitude for the same.
So this function returns all the attributes present in the dataset. So and it has returned attributes, all the attributes that are artwork, bakery, bank, bar, cafe, food court, parcel lockers, parking, skate, social facilities, so on.
In this function, we are getting all locations in a category. So the user inputs an attribute and all the location IDs for the same attribute present in the data is returned. So we have taken cafe and bank as examples.
Okay, and this function will return the ID of any location expressed in regex. And we're going to take examples of Ravs and Target. And for the first example as Ravs, and it has returned the correct ID. And the second example is Target expressed in regex, and it has returned the correct ID.
So this function is shortest path. Here we are inputting a start location, that is the source, and the destination. So we have to find the shortest path, and that is done using two algorithms, Dijkstra and Bellman-Ford. So it results all the nodes traversed and also shows the distance of the path. Dijkstra is quite faster as compared to Bellman-Ford, as we can see the time taken by function. It's about 120 times for Bellman-Ford as compared to Dijkstra. And even here you can see, for an example, Chipotle to Kava, Dijkstra is quite fast as compared to Bellman-Ford, and it is due to the Dijkstra's greedy approach. Here you can see the plotted path, the plotted shortest path from Chipotle to Kava.
Okay, and this function we are going to talk about cycle detection, and which being like given a set of latitudes and longitudes in the map, it should return if there exists a subgraph or a cycler subgraph. So we are giving two examples, one where there is no cycle in the subgraph and one there's a cycle in the subgraph. So, and this is the example where there is this present cycle in the given latitude and longitude range.
So this function is topological sort. Here we input location names and dependencies. So dependencies is the order in which you have to go from one location to another. In the first example, we had hard-coded the location and dependencies. So the sorting results are given. So it gives the most efficient route. And in the second image, you can see that we have given the paths to our CSV file. And this is the plotted shortest path as based on the dependencies.
Okay, and now we will talk about the traveling salesman problem. Like we give an n number of points, and let's say we start from the first point, which should take the shortest route towards all remaining 5 points and reach the first point again. And we are taking 5 approaches in it: the brute force method, the backtracking method, the 2OPT method, and the additionally implemented 3OPT and genetic algorithm. And these are the outputs for each method. So we are going to start with brute force, 6 points, and we have the graph, backtracking, same as well, 2OPT, and for 3OPT, and the last being the genetic algorithm.
So this function is the find nearby. Here we input an attribute like cafe and supermarket as given in the examples and a source location. From the source location, also we give radius r and number k. So radius r is the range that it can go from the source location, and k is the utmost number of locations that the function should return. Here you can see that for cafe and kava, we have been given nearby results, which are 10 in number. So this is a plot of all the, it plots all the locations around kava, which are cafes.
And this is the shortest path algorithms to a given set of points, like much more than the 2 points compared to the previous example. Um, for the first example, it takes the default present hard-coded points such as Ralph's, KFC, and Chick-fil-A, and it shows the all the traversed nodes to attain that path. And we have the distance for the given path, which is like 1.86 miles. And the second example, we have provided a CSV file, and that is Ralph's, Target, and Chipotle. And that distance comes up to 1.6 miles, and it has returned all the nodes which are traversed by the algorithm. And we are showing the graph output of the map output of the first example, which is Ralph's, KFC to Chipotle, and you can see it has taken the shortest path.
So this is our last function. Here we have to check existence of path with a constraint, and the constraint is the volume of gas tank. So here they take user input, which is starting location, source, and the destination, and the volume of gas tank available. So the main thing that the function returns is if it is um, the gas tank is enough to move from the source to destination. And here we use query. So if we have more query, it goes in a loop and it again runs the function.
Okay, and now we're going to talk about the lessons learned by implementing this project, and we're going to start the basics. Like we learned how to implement advanced coding structures in C++, like some new algorithms like classes, structures, and like harder coding implementations. And next, we're going to talk about how we learned shortest path algorithms and we were able to apply the theory learned in class to all the algorithms such as Dijkstra and Bellman Food. And the third being the use case of regex expressions, and the fourth being like us learning how to implement the traveling salesman problem using 5 approaches: brute force, backtracking, 2 OPT, and the additional 3 OPT and genetic algorithm methods. And last being the data structure implementation such as graphs, strings, arrays, and trees.
Thank you.
Thank you.